All right. So next up, we want to talk about the steps to follow to find a chain rule. And we're going to have some variable on top. I'll denote it with a little flower, and some variable on bottom. And for example, that might be something like dz dt, but you're going to follow these steps for any chain rule you want to find. So the first thing you have to do is identify the top variable for your map. That's going to be the thing that other variables don't depend on. But even easier than that, if you're finding a chain rule, it's the thing that's on top of your chain rule. Actually, I'm not going to say top component. I'll say it's the flower mark on top of the derivative you want to find. And then you're going to write out every variable that it depends on in the next line. So if I had been looking for something like dz dt, I would have said z depends on x and y and written them in this line right here. And you're going to do this below the top variable. Oops. I'm just going to say below because we'll end up looping through these steps. And you're going to draw lines to indicate the dependency, just like I drew lines between z and x and y. And then for each variable in this line, write the variables it depends on below. So really, that means for each variable in this line, go back to step 2. And then you're going to continue through to step 4 until you run out of variables. Or dependencies. So those are the words for how to create this type of map for any generic collection of functions you're given. So you could have z depends on w and x, and w depends on u and v, and x depends on y and t. And you could use every letter of the alphabet and then have to switch over to the Greek ones, and you could do this. So after you've looped through this section right here to create your diagram, you're going to find your independent variable star everywhere in your bottom row. I think we're on step 7. So you're going to highlight, draw, whatever you need to do. And you're going to want to start at the top down to any possible star on the bottom in your diagram. So, for example, here, if I was trying to get from Z to T, I could take this path, or I could take this path. That's what I mean by highlighting paths. And then along a path, you're going to multiply each partial derivative represented by the dependency lines. So again, going back to here, I have a line that shows z depends on x. So that partial derivative would be that z depends on x. And here I have x depends on t, so that one would be dx dt. So at the end of my path, I'm going to multiply everything together, dz dx times dx dt. And this should look like your regular chain rule that kind of cancels out derivatives. Multiply each partial derivative represented by the dependency line. Okay, and then so add up these products you find in 8 for every path highlighted in 7. And that will give you the full derivative d flower d star. And these steps can sound kind of complicated when I've written them all out this way, but I promise as we work through examples, you're going to see that this is actually pretty simple and intuitive, and it's a great chance to practice taking all these partial derivatives that I know we've been kind of learning for the first time recently. So we're going to work through just a lot of examples right